Let's put intersections under the microscope. Here's the thing. When I initially started preparing the content for this episode, I originally thought intersections, it will be a short topic, right? Well, it turns out that we have a lot to talk about intersections. This episode will help you understand their syntax. We will see when and why we need to use an intersection. We will talk about their weird parts, and trust me, intersections have some very weird parts. Then we'll do a deep dive to understand the concept behind intersections in general, and then we will compare them with different types, for example, unions or the extends keyword. It's gonna be a really interesting topic, and yeah, you should watch this episode and stay until the end because I have a big announcement for you. Okay, I'm ready, so bring it on. Come, fast. Hello friends, it's Nikos here and welcome back to the channel. If you're new here, this is a channel about creative programming and you are watching my free course about TypeScript. So my goal is to help you learn everything about TypeScript and to become a better software engineer. Plus you get for free nice animations, relaxed music and my Greek accent. Okay, that was not in the script, but anyway, if these TypeScript concepts sound Greek to you, then you will find a link in the description down below so you can watch this course from the very beginning. And that's all about the new joiners. Now let's answer the million-dollar question. What's an intersection? To understand the concept behind intersections, let's review one of the examples we have seen in one of the previous episodes. Basically, we had something similar like this one. We had the song type and the video clip type, and as you can see, these types have some common types, common properties. So, for example, file name and the play method is basically the same between these two types, but they have different extensions. So one of the use cases of intersections is to help you reduce all this duplication between these two types. What we can simply do is create a third one. Let's say that this is the file base, and here we can move the common properties. So now I am removing these two properties from my types, and check this out. I can say that song is actually an intersection between file base and this object notation here. And the same, of course, applies for my video clip, file base, and I'm using this ampersand here, and this is actually the character that we use to define an intersection. And yeah, that's it. Now, if I hover over one of these two types, you will see that this is basically now an intersection. So what this practically means, let me try to illustrate it here. So this is a representation of what these two types will contain in terms of properties. As you can see, song, for example, will have all the properties from the file-based type, and the extension will be MP3, and the video clip will have same properties, plus the extension will be MP4. And yeah, this is basically how an intersection works. In TypeScript, we can use an intersection to merge two object structures into a new one. This will basically create a new type, which will include all their unique members, as long as they have the same type, and any other extra properties or functions that you want to declare. So intersections will help us mix and match different object structures, and this is extremely useful when we have a lot of repeatable properties across all these different types. For example, all of our objects have IDs, and you know, what if you have a complicated ID pattern? For example, this interface here, ID, it defines the ID property, but our IDs are a little bit tricky. They start with the letter U or X, and then they have a dash and followed by a number. So if we want to specify that no matter the object, this will be the ID everywhere, what we can do is create an interface ID, and then we can have our types. For example, here we have a user, and we can specify that this user will have an ID plus these two properties here, the username and the email. And the same applies for the order. The order will also have an ID, and yeah, we can have a number to represent the total amount. You can also create intersections on the fly. For example, if I have a user with an order, I can use an intersection here, and then I can assign an object that it's basically an intersection, and I can paste an order here. And yeah, as you can see, this will include the ID interface here, and as you can see, this will include basically all the properties that these three types have combined. When it comes to intersections, there are some weird parts you need to understand, and I would like to present them right away. So far, we were using object structures. You may be wondering, will intersections work with literal types? So here, for example, we try to create an intersection between a boolean and a string. What the result will be? Will this work? Well, the answer is no. Intersections will not work with primitive types. Intersections only work with object structures. That's something you want to remember. Even if you try to compare them, for example, I have a literal type and I have an object structure, the result will be the same. It's not gonna work. And now you may be wondering, okay, what will be the result? I don't see any error here. So let's try to figure it out. I would like to hover over the first one, and we get back never. So basically, we cannot have a boolean that is also a string, right? This is impossible. That's why TypeScript will assign the wildcard never in this type. And we've seen never wildcard before. It's basically, it means no type at all is allowed to be assigned in this variable. So what about the second one? Here, this took me a while to understand what will actually happen here. If you can see here, the text editor, yes, will show you that here there is an intersection, not like the previous one, but that's a quirky behavior because let's try to create, let's say, some variable which is what about me, and here let's try to assign a string. As you will see, TypeScript will not allow us to assign anything in this variable here because it will tell you string is not assignable to this type. And even if I try to have an object with a name, I will get back the same result. That's because, yes, this will be never again. But what is happening here is we don't basically see the never because we see the intersection, but we need to remember that an intersection between literal type or multiple literal types will simply not work. Another interesting question is, what will happen if these two types have common members? So what, for example, will happen if I have an intersection between a type that has a property and I also define the same property? So let's see what behavior TypeScript will have here. So I'm going back to the previous example. If you remember, we have the ID, the user, and the order. And what I want to have again is a user with order. And here, let's create an intersection between user and order. So now, if I start creating a new object, you will see that we get the email, the ID, the total, and the username. So let's spice it up a bit. What will happen if both user and the order types have, let's say, the created at string? So let's declare this in both these two types. Will this be inside my user with order. Let's figure it out. So as you can see, yes, created that will make it, and it will be a string. So if you have common types between the two different object structures that participate in an intersection, you will actually have these members will be in the final object structure. And now I have another interesting question for you. What will happen if I have the same property in these two types, let's say status, but here I declare it as a string, and here, for example, I declare it as a number? Will this be in the final object structure? Well, let's figure it out. Actually the status is here, but wait for it. If I hover over status, you will see that the type is basically never, which means that status is here, but no matter what you try to assign here, if you try, for example, to assign a number, TypeScript will not basically allow you, because basically nothing is assignable to a type never. And this, my friends, means that an intersection of two types that have common members will only work, these members will be in the final object structure only if they have the same type. And that's for a good reason, I think. And now you may be wondering from where intersections got their name, why they called intersections. It turns out that this comes from math, and especially more specifically from the theory of sets. A set is a mathematical model that represents a collection of different things. We programmers call it array. So if we have, for example, a set A, which has some kind of stuff inside, and another set B, which also has some other stuff, the intersection between these two sets will be another set, a new set, that will only contain their common parts, so the ones in the middle. And now you may be wondering how this is an accurate name, because previously we've seen that with object structures it doesn't behave exactly like this. So for example, we have an object structure that has these members here, and we have another object structure which has different members. So the intersection will be the members they have in common, or all of their members together. Well, it's complicated. Most of the times, if you don't have common members as we've seen, it will be all the members together, which somehow makes it a union, I would say, and not an intersection. And this is a bit confusing. Why the hell TypeScript developers decided to name this feature intersection? I have to admit that it took me some time to understand the concept here, but I have to say it does make sense. So far we were checking object types, and we said that intersections don't work with primitive types, but they do work with literal types. So if you have, for example, a union of literal types, let's say something that represents the movie, and another set which represents a song, then the result of an intersection will be the intersection of these two literal types. So you will only get the types they have in common. Everything else will be excluded. Here's a representation of the previous example. We have the song metadata, which has a length, an album, a title, and an artist. And then we have the movie metadata, which says the length, the director, and the title. So now, if I want to create a type that contains the common metadata, what I can do is declare an intersection of song metadata and movie metadata. So if I hover over here, we will see that the result is basically the common literal values, the literal types. And here you will see that length and title are appear in both these two types, but album, director and artist are unique. And I hope this makes it a little bit more clear to understand how intersections are meant to be used. And the object structures are a bit more difficult and they have their weird parts as we've seen before, but I think when you use literal types, it makes total sense. Now let's compare intersections with unions. So if you have, for example, two different object structures, as we've seen, an intersection will merge their common or sometimes not common members. But the union, we said, is like an array. So the union, instead of merging these objects, it will give you the possibility to assign either one of them or the other. So basically, you have an array of acceptable values. Now, if you are dealing with literal types, then you basically, if we have to compare this example we've seen before with intersections, if we have to use a union here, then the result will be basically all the literal types together. It's not only the common values, but basically any value. And this is how a union compares to an intersection. And now let's see how this translates to code. Back to the previous example, here we used an intersection to have the common metadata. Now we can have all metadata and we can use a union. So here, song metadata, union, movie. And as you may guess, this will include all the different values, unique or common. And this is how a union compares to an intersection. And it's actually really useful when you are working with literal types. And we've seen back then when we discussed about unions, how unions could be used with literal types, especially the episode about mapped types will be really, really interesting for you. And I think intersection somehow completes the puzzle here for us. Okay, I hear someone from the audience screaming, wait, what's the difference? Can you compare intersections with the extends keyword? They are both the same, right? What's the difference behind these two? Well, let's see. Remember our previous example with the ID interface? Here we are creating a user that has the property ID together with some extra properties. Well, it turns out that we can have the same result, but by using the extends keyword. Now, the extends keyword is kind of special because the extends keyword is supported natively by JavaScript. So, especially latest features of JavaScript, right? This means that you can use the extends keyword to implement some object-oriented structures. So you can use it with classes as it is normally used. But you can also use it with interfaces in TypeScript. And that's a TypeScript-only feature, but you cannot use the extends keyword with interfaces. So if I try to use the extends keyword here, it will really not work. So what I have to do is to convert this to an interface. And let's do exactly that. So let me comment this out and let's paste it here. And I will rename it to an interface. And remember that interfaces don't need this equal sign here. And instead of this one, we can say that the user extends ID and the structure is this one. So basically this will create an interface user and it will have the same result, the exact same result as if I had used the intersection. So these two are completely identical. So now let's answer the question when and under which circumstances you can choose between these two. Let me give you a practical way to decide on that. Basically, if you have a project that uses classes a lot and you have a lot of object-oriented structures, then you probably want to use the extends keyword, because it will be available also at runtime. This makes it much more useful. If you don't care about classes or object-oriented programming stuff, then in all of the situations I would use intersections. That's because of the limitations of the extends keyword. You can only use it with statically known members, so you cannot use it with dynamically generated types. And this is exactly what we want to do with some of our types. And of course, you cannot use it with literal types. And I think that's how intersections are a much better solution for you. Intersections are kind of difficult to use, and I think that's the reason why the official documentation page is currently removed or refactored. I think there are more features in TypeScript that are more important than intersections, but I hope after watching this episode you have a better understanding on how to use them in your projects. And you know the drill. The blog post, the playlist, the like and subscribe buttons. But this time, I have something new. I'm really excited. I have launched this channel and it gives me a lot of joy being here and teaching you new stuff. My initial goal with this TypeScript series is to help people understand the importance of TypeScript and to discover together all of its features, to become better software engineers. So we started with baby steps, and now we are exploring some really advanced concepts. I was looking for ways to improve this course, to make the whole learning experience better for you. That's why I have created something really cool. Introducing the too long to read TypeScript.com. This is the official Students Companion page, which starts with this very nice landing page, and it kind of explains the goal that I have with this course and what it includes. And it's basically an index that includes all the videos and the articles of this series in a more structured way. So I grouped them into chapters to make it much more consumable. And I will be adding a lot of features to make it like a real course, like a complete course. But don't get me wrong, this course will remain for free for everyone who wants to learn TypeScript. Both these videos in this channel and the official Students Companion. As you may have guessed, this is not just an index page. It will not stay as an index page for these videos. It will become an actually fully fledged course. So my plan is to basically break all these videos apart into smaller parts, smaller chunks, and create a much more interactive experience. So without advertisements, without like and subscribe prompts. I mean, everybody hates those, right? You will have the option to choose what you want to watch and to consume it in a nice way, including some interactive parts like coding examples and mini games. If you want to help this channel grow, there is already an option to contribute, and I will be announcing some premium content for my supporters soon. And one more thing. In every episode, I will be announcing some exclusive bonus content for you. As you may have guessed, this channel is all about surprises, so click here to subscribe. And check my playlist here if you want to watch this course from the very beginning. All the episodes, 100%, you will find it here. Until the next one, thanks a lot for watching. Let me know if you have any questions and have a creative day.